Hello and welcome back to episode 2 of Science at Home with me, Dan Nickstrom. So the last time we talked about speakers and how speakers worked. We really dug into that. Today we're going to look at a different object in the home, the fridge. How does a fridge work? It keeps all our food cold, but how does it keep it cold? So just like the last time, we're really going to dig into it, we're going to tear it all apart, look inside and figure out, just like a physicist would, how it actually works. Can we use the chainsaw? No, we are not putting up the fridge with a chainsaw. I need that to keep my food cold. Sorry about that. Okay, let's take a look inside by opening the door. What is cold? What is hot? If the air in the fridge is cold and the air in the room is warm, how is that air different from each other? What's the difference between hot air and cold air? Let's go and figure it out. Okay, so now we're going to get to understand hot and cold a little bit better. But first, I'm going to ask you just to run into the kitchen and grab a metal spoon and a wooden spoon, if you can. I'll give you a moment. Okay, did you get a metal spoon and a wooden spoon? Don't worry if you didn't, but great if you did. You can put them to one side for a minute. First of all, what we're going to do is we're going to try and understand what matter is. So what's matter? Matter is solids, liquids and gases. Everything you can touch and breathe and interact with. That's matter. So just like a Lego house is made up of lots and lots of little tiny blocks and pieces, all matter is made of lots and lots of little tiny pieces. And I'm going to use these peppercorns to represent them. Now the tiny, tiny little pieces that matter is made up of, we call those atoms. So everything is made up of atoms. If you're in a room like this and you're breathing air, there's atoms of air that you're breathing in. In a cold room, those atoms are all jiggling about really slowly. They just jiggle about like this. They're all in motion all the time. If the room gets warmer, you light the fire, you turn on the heating, they jiggle faster. In a cold room, they jiggle slowly. In a hot room, they jiggle fast. So the only difference between cold air and hot air is hot air's particles move faster, cold air's particles move slower. Okay, so really heat is just vibration. Very similar to sound, it's just a vibration. Now I'm going to ask you to use the two spoons I asked you to get earlier to think about how heat moves around. Take the wooden spoon and the metal spoon. Put the metal spoon against your cheek. It feels cold, right? Put the wooden spoon against your cheek. It doesn't feel quite as cold, right? The metal spoon should feel colder than the wooden spoon. But hold on, they're both in the room here. They both should be the same temperature. My thermometer says it's 21 degrees. So both of these should be 21 degrees. So why does one feel cold and one feels warm? Well, the reason is this. Metal is a really good conductor of heat. It means heat can easily move through it. So when I put the metal spoon against my face, all of the atoms of my face that are jiggling around really fast move really easily into the spoon. So that jiggling force moves into the spoon and it feels like the spoon is cold, but really the spoon is taking heat from my face. So my face gets colder because the heat moves into the spoon. When I put the wooden spoon against my face, wood isn't very good at conducting heat. So the jiggling that's happening in all the atoms that are making up my face doesn't really transfer into the wood. It doesn't absorb it as well. That's why it feels warmer and this feels colder. It's just got to do with the material. It's the same if you stand on tiles, they feel colder than carpet. It's the exact same principle. Okay, so let's go have a look back at our fridge and see what else we can find out. Heat and temperature aren't the same thing. When we give heat to the water here, using the flame, it increases the temperature of the water. The temperature will keep increasing until it hits 100 degrees. That's the highest temperature water can hit. Then it starts to boil. Something very interesting happens here. We keep giving heat, but the temperature doesn't go up. It stays at 100 degrees. So where does the heat energy go? Well, the heat energy goes into changing those molecules of water into molecules of steam. It evaporates the water and that takes a lot of energy. So whenever we go from liquid to gas we absorb a lot of heat. The same thing happens when you sweat. The liquid comes on your skin and it evaporates off and it takes heat from your body, which cools you down. The opposite is also true. If we get steam and it turns back down into liquid, well then it's going to give a lot of heat. So that means a burn from steam is a lot more dangerous than a burn from liquid because it gives a lot of heat to your body. One last thing we want to look at before we take a look at the fridge. So if we compress a gas, it gets hotter because the same amount of jiggling atoms are in a smaller space. If we stretch out a gas, it gets colder because the same amount of atoms are in a larger space. Remember that. Okay, so I didn't want to dismantle the fridge I'm using, so I took this other fridge and I've turned it around to show you what's behind it. Now, to keep objects cold, the best way to do it is keep moving cold liquid round and around them. If you keep doing that, you'll keep objects cold. But the hard part is, how do you keep the liquid cold? So all of this contraption that you'll see at the back of a fridge is all just to keep liquid cold and keep it moving around. So let's explain how this actually does that. Now, these tubes that you're seeing here, all these tubes, they're filled with a liquid. It's called a refrigerant, okay? It's a special type of liquid that boils at a really low temperature. Water boils at 100 degrees. Refrigerant boils at a far lower temperature. Maybe 20 degrees, maybe 25, something like that, okay? So the liquid starts in here and it's at a high enough temperature and it's at a high pressure. And it gets pushed through here into this tiny narrow little tube that goes through here and goes round and round and round. This tiny narrow little tube. Because this tube is so tiny and so narrow, it's pushing with a high pressure here, but it's so hard for it to get through that by the time it gets to the end of the tube, it's at low pressure. Remember we talked about high pressure and low pressure? Well, something else about low pressure liquids means they boil at an even slower temperature. Okay? If you're at the top of a high mountain where the air pressure is low, you can boil water at 80 degrees. So here what you're doing is you're lowering the pressure so that the refrigerant boils at an even lower temperature. Okay? So it comes through here, and in order to see what happens here, we're going to have to dismantle our fridge. Before I take it apart, I've plugged it out, and I know it's safe to do what I'm doing. But once again, don't try this at home. Only do something like this if you're with a qualified adult. You can do a lot of harm here. These pipes are filled with flammable liquid. That's why that fool with the chainsaw wasn't allowed to come anywhere near it. You could do a lot of harm if you break those open. So make sure you're careful. Okay, here we go. I'm going to start dismantling. People are complicated, but that's got consolation. Whew. Okay. We've dismantled our fridge so we can see the parts we want to see. Right, so let's remember where we were. We had this narrow little tube, yeah, which had that low pressure gas coming into it. So that low pressure gas means that the refrigerant is going to boil at a lower temperature. Remember, when we say it boils, we don't mean it's really hot like boiling water. This particular liquid, refrigerant, boils at a very low temperature. So it's going to move through this tube, this silver tube, and those tubes run the whole way around, down here, the whole way around the entire fridge. And what we want to do is we move this liquid that's starting to evaporate, because it's at its boiling point, the whole way around. Whenever a liquid evaporates, it needs heat. So it's going to pull heat in from wherever it can get it. And it can get heat from the inside of our fridge. That means it cools down everything in the fridge because this liquid is evaporating. Now, it's contained inside the tube, so it can't go anywhere. It keeps moving around in these tubes the whole way around until it comes back up here through this larger tube and into this big black device. This is called a compressor. It compresses air. So it takes this low pressure refrigerant, which is a gas, and it compresses it until it's really compressed down. Now remember from earlier, we said when you compress anything, it becomes hotter. So we now get this hotter gas moving through these tubes here. They come out the other end of the compressor and they move through these tubes. The whole way along these black tubes. Now these are mounted on the back of the fridge. Yeah, not on the inside, on the back. So that means this hot refrigerant gas that's moving through these tubes starts to give off heat. and that heat comes off at the back of the fridge. And that's why if you ever thought you could cool a room down by leaving the fridge door open, that won't work. Because it cools down on one side, but it pushes all the heat out in the back. So a fridge actually warms up a room. Anyway, so this refrigerant is now hotter and it's moving around here, giving off heat. So as it gives off heat, it's going to cool down and it's going to turn back into a liquid. So by the time it gets the whole way around here, it's giving off all this heat, it's after losing some of that heat, cooling down a bit, and now it's just back where we started again. And it can be passed through this tiny little tube and drop the pressure because it's being pushed through this tiny narrow little tube, and we end up with this low pressure gas again that's going to go and evaporate and pull more heat from everything in the fridge, and the whole cycle continues over and over again. So if you ever put your hand on the back of your fridge, you typically feel that it's warm at the back, and that's just so we can keep it cool on the inside. It steals all that heat from the inside and pushes it to the outside, and it all happens through compression of gas, boiling and condensing of liquids, and just a little bit of clever engineering. So there you go, we learned a few things about heat, about cold, how they work, and hopefully you now have a better understanding about how a fridge works. So I'm going to clean up this mess, and I'm looking forward to seeing you already on the next video. Take care. Can you just put that stuff back up there, please? Help me, please. Slavik.